Okay, so we continue with motion planning, and now I want to talk about degrees of freedom of a robot. So let's understand what it means. So generally, when we look at a robot, and let's start with a two-dimensional example. When we look at a robot, we can specify what is the placement of the robot. If the robot can also translate in the environment and in two-dimensional, I can make the robot, for example, like this, and it can translate. So let's define this one as the origin. Let's define it as 0.0, and let's define robot as r. So r 0.0 is this one. So I can take this and put it right over here. This is the placement of the robot in starting. Now the robot can only translate. It cannot, for example, rotate. So I can define it as x and y position. Now when we go to a general position, for example like this one, I can say that the position of the robot placement is some x and y. If you want, if I define the axis, for example this is, I don't know, 5 and this is, I don't know, 4, so the robot here is at 5, 6, 4, right? And generally this is the placement. Now if I'm talking also about rotation of the robot, there is also an angle. Let's define it as counterclockwise rotation. So I can define the robot not only by x and y, but also by theta, by an angle. So for example, I can have a robot which is, again, start with here at the origin. Here it is, and it's not rotated, so I can say it's in 0, 0 and angle 0, and it can move to, for example, right over here. It's rotated, I don't know, for example 45 degrees. So here, for example, it's 45 degrees, and this is the position. So I can say that, for example, if this is, I don't know, 4 and this is, for example, 6, so here the robot is at 6.4.45 degrees. So the degrees of freedom of a robot is how many parameters I need to define its placement. Now when the robot can rotate, I have this angle. When it can rotate, it cannot rotate, I have only 2 parameters in a 2D translating robot. So for this robot, for example, I have 3 degrees of freedom because I have x, I have y, and I have theta, which define its placement. And here I have a robot with 2 degrees of freedom because I have only x and y. So the degrees of freedom of a robot is how many parameters I need to define its placement based on what it can move and where it moves. Here it moves in 2 dimensions. If I'm going, for example, for the 3D dimensions, for only translating robot, I can say that I need x, y, and z. So 3 degrees of freedom for a translating only robot in 3D dimension. But if it can translate and rotate, so I have more 3 angles for moving. So I have r, x, y, z, I don't know, and some angles. So here we have 6 degrees of freedom. So you understand that the degrees of freedom of a robot depend on how can the robot moves and in what environment it moves. Okay, so this is it. This is about degrees of freedom of a robot, and thank you very much. If there are any mistakes or corrections, please tell me, and that's it.